Hello everyone, today we are going to perform a detailed analysis of project network diagram to determine the most efficient way to manage both time and budget. We'll be evaluating how to optimize project schedules through a process known as crashing. Let's begin by reviewing the core data provided in our exercise. The problem presents us with a narrow diagram consisting of 4 primary activities, labeled A, B, C, and D. We are also looking at a comprehensive dataset that lists the normal duration and cost for each task, compared against the crash duration and its corresponding higher cost. If we examine the table, we see that the activity A normally requires 4 days at a cost of $80, but it can be accelerated to 3 days if we increase the budget to $105. Activity B takes 6 days for $180 or 4 days for $250. Activity C requires 80 days at $200 but can be shortened to 5 days for $320. Finally, activity D normally spans 10 days at $350 but can be compressed to 6 days for $530. Now we are diving. Then we start on part A, identifying the critical path. Our first objective is to identify the critical path. In project management, the critical path is the longest sequence of dependent activities that determines the shortest possible time to complete the entire project. By looking at our diagram, there are 2 distinct routes from the start node to the finish line. The first route consists of activity A and D. Using their normal durations, this path totals 14 days. The second route consists of activity B, C, and D. This sequence totals 24 days. Because the second path takes the longest amount of time, we define B, C, D as our critical path. Part B, standard compression and cost. Now, let's determine the standard project compression time and the total normal cost. The project compression time is simply the duration of a critical path, which is 24 days. To find the corresponding cost, we sum the normal expenses for every activity involved in the project. When we add 80, 180, 200, and 350, we arrive at total normal project cost of $810. Part C, optimizing the crash schedule. Finally, we must find the best crash time and the resulting cost. Crashing is the strategy of spending extra money to finish the project as fast as possible. First, let's find the absolute minimum duration. If we push every activity to its limits using the crash times from our table, the first path will take 9 days, while the critical path will take 15 days. Since the project is only as fast as its longest path, our best crash time is 15 days. To calculate the most efficient crash cost for this 15-day schedule, we must fully accelerate activities B, C, and D because they are on the bottleneck path. However, since the first path is already well under the 15-day limit, we can keep activity A at its normal speed to avoid unnecessary spending. Our final budget for this accelerated schedule includes the normal cost for A and the crash cost for B, C, and D. Summing 80, 250, 320, and 530, we find that our best crash cost is $1,180. To summarize our findings, the critical path is B, C, D. Under normal conditions, the project takes 24 days at cost of $810. If we need to finish as quickly as possible, we can reach a 15-day deadline for a total cost of $1,180. Thank you for following along with this technical breakdown.